Okay, looks like we are live. I'm gonna make sure, just for anybody watching this tutorial in the future, I'm doing this as a live stream so that I don't have to worry about uploading stuff and whatnot. I just want to make sure things are good, so I'm gonna go on my phone. This one will take a second. Great. Okay, looks like audio is fine, looks like video is fine. Great. Okay, so let me give you guys a brief. This could be minimized. Oh boy, this could also go. And goodbye. Okay. This is going to be just a bit of an idea of what we're doing. We're going to be making Connect 4 in Golang, which is a programming language relatively new, made by Google. You should know how to program in Golang before you watch this video. It's a prereq. I'm not going to be going through that. I don't have any tutorials on my channel for Golang just because there are so many, and it would be a waste of my time and your time to do it with me. So I linked in the description a good tutorial playlist by Tech with Tim for Golang. It's a little bit old. It's like 2 years old, but it's fine. Nothing really changed. That's important. I mean, a lot's changed. A lot's changed that is important, but nothing for this video that's changed. So go watch that video if you don't know how to do anything with Golang before. If you're coming from Python, that's going to be great. You'll follow along with this tutorial excellently because I'm coming from Python. I've been coding in Golang for 2 years now and Python for like 5 years now. So I'm a Python guy. I came from Python to Golang. I still program in Python a ton because I love machine learning and Python is great for machine learning. But I'm in love with Golang. Like, I love Golang. It's my favorite language by far. I wish everybody used Golang. I wish we would make a TensorFlow, PyTorch, NumPy, everything. I wish we would just make stuff like that for Golang. It's a great language. It's great for that stuff. I don't know why people aren't doing it. Very upset by that, but that's fine. Whatever. I digress. Anyway, recently I watched a great tutorial about the minimax algorithm for Connect 4 in Python. So a person made Connect 4 in Python to make the minimax algorithm with it, and it was a great tutorial. Two videos. One of them to make the actual game, and one of them to make the AI with the minimax algorithm. So I'm going to just do that, basically exactly what he's doing. In fact, I really should link his stuff in the description. Hold on. So let me just find that stuff. Connect 4 Python. I should give him credit. I think it was this guy. Yeah, it was using the freecodecamp.org. I don't think this is the guy's original video, but whatever. This is what I use, so I'm going to give this credit. So, edit, description, I guess, inspired by, boom. That's how you spell inspired, is it? Save. Okay, fine. So great. So that is that. So yeah, so he made Connect 4 in Python, and I made it yesterday in Golang, just the game, not the AI. This video will be about making the game. The next video I'll make one implementing the minimax algorithm in Golang for this AI, because something like minimax is great. It's very bad for Python because Python is slow, and minimax requires a lot of computations. It's recursive. So why are we doing it in Python? Now, the obvious choice is to do it in C++, but guess what? C++ sucks. I hate C++. It's a terrible language. It's really annoying. Really annoying to code in C++. So Golang solves all these problems. It's awesome to code in, just like Python. It's fast like C++. I've even done some tests where in certain computational areas, Golang even beats C++, which is mind-blowing, but that's very few. Most of the time it loses, but only by a little bit, especially compared to Python. So great, so we're going to be making it. Now let me show you what we're going to be doing. Let me show you what we're going to be making. So this is just, I've coded this up. This is all the code. Great, so this is the game. Basically, it's Connect 4. Exciting, right? Let's make yellow win. Great, so player 2 wins. Awesome, and now, by the way, the way I coded it yesterday has some, not problems, but not perfections that I'm going to be fixing in this tutorial. I'll make it a little bit better. So anyway, we're going to be making this game. Basically, you play until someone gets a Connect 4. Then it says that the certain player wins. You click again, and it resets the thing. And basically, it's all about the mouse button. So as you can see, the Connect 4 board is a 7 by 6 board. And we're going to need space up top here to make this little thing. We're going to be using the raylib library. Raylib is a graphics library made for C++. Awesome library. Why is it so awesome? Because it has bindings, it has key bindings in so many languages. It has one for Python. It has one for, I mean, let's just check. Let's just check. Raylib. Okay, it has, this is not the key bindings. Where are they? Okay, here. It has a binding for C#, Golang, obviously. Not sure what this is. Python, Rust. Not sure what this is. Not sure what this is, and even more. And it's got a ton of stuff. It's got a physics library. It's got audio. It's great. So obviously we're going to be using the one for Golang. Now, how do you get Raylib for Golang? Well, let me show you. When you get Golang, let's find where it is on my computer. Should be somewhere here. Go or something like that. Drivers Intel. Oh no, users. This is my brother's computer or my brother's old computer, so it's a Kiva. Go. Great. So you have a folder. Whenever you get Go, you could get it at this place. Just download Go. Honestly, you should have that. So basically, what you have is you have a script folder, and then here's a bunch of stuff. So, oh my god, I don't even know how to explain this. Golang, Raylib. The way you get packages for Golang is you. No, I don't want to be here. I don't want to be at the GitHub place. The way you get packages for Golang is you go to pkg.go.dev. You get all these packages. You can search for whatever you want. So type in, I mean, we're already here, but just type it in Raylib. This will help you get started for Raylib for Go. Sorry, I should have explained that we're doing that. Yeah, this is the one I'm using. So great. So to do this, to install it, to get it, you're going to copy. In fact, let me just quickly delete the one that I have. So github.com. Gen2Brain, so okay, great. These are all the other packages that I have, and if you see right here is Alicia Schmala. This is where I keep all my programs. So to download it, you type in on your terminal or command line or whatever, go get, and then boom, the path. How did I get that path? I got it up here, right? You copy it, go get the path, bada bing, hit enter. I don't think it puts out any output, which is super annoying. It doesn't tell you like succeeded or like you did it or like yay. It's just nothing. So the way you check it is, well, give it a second. At the very least, it will show like a new line where you could type new stuff. So once it does that, that way I'll know that I got it. But as you can see, it's significantly slower than pip. Pip is much faster. And honestly, package and like library management for Python is such a pleasure. Such a pleasure to work with packages in Python. You just do pip install whatever you want, and it's there, and you can use it, and there are no problems. I didn't realize what a blessing this was until I started learning C++, and it was like, oh my god, C++ was a nightmare. I tried learning that language. I learned the syntax, but after that, I didn't use that language for anything. Such a terrible, terrible language. Like, terrible. Made by sadists, and just horrible, horrible language. No, honestly, it's an incredible language. People use it. It's incredibly fast. It's an amazing and powerful and beast of a language if you know how to use it, which I don't, and I don't want to, so it would take way too much work. Not interested. So Go, for me, is perfect. Go has like the beautiful syntax of Python, easy, pretty nice package management, honestly, like really nice. Just Go is such a pleasure to work in. I wish everybody coded in Go. I really do. Why is this taking so long? New? People? It really should not be taking this long. I did this right? This is how you do it? Ah, there you go. Great, so, okay, we got it. Now, the way you would check is, first of all, go to your Go directory, your folder, scripts. This one, since it starts with GitHub, it will be in the GitHub folder. Gen2Brain, so you should have a Gen2Brain folder now. Raylib-go, and then Raylib. So this is basically this is where everything is. This is the package. And to delete packages in Golang, you just literally select the folder and hit delete. It's very primitive. So you would go to GitHub and you would select Gen2Brain and right-click and delete. Now, very important for your environment variables, which is really annoying to work with on a Mac. Environment variables are great to work in on Windows. So you should have an environment variable called GoPath, which is the directory to your GoPath, and you need that. You need that badly. You will not be able to work with your packages unless you have a GoPath thing, and also a Go root. Yeah, you need both of these. You need a path to your Go directory, and also you need a thing to the actual Go program file to run stuff. Anyway, great. So that should get you Raylib for Go. Now, let's set up a hello world example. So I'm going to make a new window, and this is going to be hello. Thank you. Command open. So I'm going to go to, right, I have it in my quick access thing, but I'll just show you how to get there. Basically, what I could do is I would go to, let's just start at the beginning, the C drive, users, that. This is where I keep my Go directory, so that's where it is. You might have it somewhere else, I'm not sure. Scripts, github.com. This is my GitHub username, so I have a folder with that, and here is where I keep all of my Golang projects. This is how I organize my Go code. I don't organize my Go code as you're supposed to. I don't do it. I should probably start. I don't. It's annoying. I organize my Go files like they're Python files. So yeah, that's just how I learned how to code, and that's how I do it. So anyway, I'm going to make a new folder in my Go projects, and I'm going to call this tutorials. Tutorials. How do you spell tutorials? Tutorials. Why not? So great. So now I'm going to go into this folder, and I'm going to make a new one. Sorry for the voice crack. Connect _4. Should it be a number or should it be a letter? I don't know. Okay, 4. There you go. Great. So now I have the folder open, and great. So let's start writing the code. So obviously, as you should know, main.go. This is going to be our main file. This is where our main function is going to go. So package main. Just show that this is the main package. Let's do func main, and then just fmt. I'm able to, since I'm using Visual Studio Code, I could just type whatever package I want, and it will just import it for me by itself. fmt.println hello. Let's just make sure everything is running. So let's get a terminal, new terminal. This is not how you spell main. Thank you, Visual Studio. Code. So now, the way you run a Go file is you do go run and then main.go, right? But since I'm going to have like many files in this one directory, we're going to have like multiple things here. I'm not going to do, let me just check the chat. I had a chat open, right? Didn't I? Not sure. Yeah, it's up here. There are no chats? No one's chatting? No one's watching the stream? Great, that's fine. I don't care. I mean, like, this is supposed to be just a tutorial video tab on my channel. The reason why I'm live streaming is just so I don't have to upload it, and it will be uploaded by itself. So anyway, so since there are going to be multiple files here, the way you would run a Go program that is using multiple files is you would do go run dot. And the dot stands for everything in this directory. So it's just hello, and there you go. So everything is working great. Obviously, this would be the same as doing go run main.go, but I don't want to do it like that just because then I wouldn't be able to use the other thing. So we're going to do go run dot. All right, now I like to leave this line here. I like to leave an fmt.println hello in most of my Go files. Why? Because if I don't, it will automatically de-import fmt, and I don't want that. I want to have fmt on my disposal, and I don't want it to throw any errors, because in Golang, if you don't use a package that you imported, if you don't use a variable, everything breaks. Which, pros and cons, not going to get into that right now. But anyway, so I'm going to keep the fmt. On the other hand, we need to import another thing. So we need to import Raylib. So let's do that. Now, I know this by heart, but if you don't, just go to your, I'll just do it this way. Go to your thing, go to your Go path. We've done this before. Scripts, github.com, Gen2Brain, Raylib.go, Raylib. Copy from the GitHub, including the GitHub, for the rest. Why? Because this should all be your Go path. And so that's your environment variable, and it knows that you need the rest of this. And Golang, the Go compiler, will look at your Go path and then look in your computer for this stuff, and it will import the Raylib module. So what's the problem? Invalid import path. Ah, right, yeah, because I can't do backslashes. It has to be /. So I have to just manually fix that. Any problems now? Package Raylib, Go bindings from Raylib, a simple, yeah, so great. So it found the thing, and then there's an error because I'm not using it, so I have to use it. So one cool thing you could do in Go is you could put an RL over here, and now whenever you type RL, that will reference this. It's basically like saying import Pygame as PG in Python, so that's the same thing. You just put the RL over here, and now you reference it as RL. Again, working, like, as someone that's coming from Python, I used to code a lot in Pygame because I love game development. Not game development, I love AIs for games, so Pygame was great for that. Okay, rl.init window. This is how you set up a window in Raylib. Let's give it a width of 500 and a height of 500. This is just like a hello world thing, and we'll call this connect 4. And then we'll type defer rl.close close window. Yeah, rl.close window. So the defer keyword in Golang, I don't know if you guys know this, you should know this, but if you don't, the defer keyword basically says, at the end of doing everything in the function, do this. So it's basically just wait until we're done everything else in the function and then do this. It's a great way of, like, if you need to clean something up, if you need to close a file, if you need to exit a web browser or something, whatever, at the end of your function, this is a great way to do it. Just whenever you start your Raylib window, just defer to close it, and that way everything will run nicely. So if we do go run dot. Okay, and it went away. Right, why did it go away? Because you need a game loop, obviously. So let's say running colon equals true for running just if rl.window should close. This is how you handle in Raylib. This is also, by the way, you don't need to know Raylib to follow along. I should be explaining things pretty okay. If you know Pygame, it'll be great. But I'm going to try and explain things just so that I also don't see any tutorials on YouTube for Raylib in Golang, which I don't like. I love Golang. I wish there were more tutorials. So anyway, Raylib is a great graphics library to use in Golang, and that's what we're using. So Raylib.init window, this initializes the window. Raylib.close window, this closes the window. And basically what we're going to do is we're going to make a game loop. So running colon equals true for running, which in Golang is like while running, while the game is running. If rl.window should close, this basically means if user hit the X button, if user quote unquote X is out, I guess, then running equals false. Now we run this. Great, so nothing is happening in the window because I forgot to do important things. So this is going to break. So we have to actually command C out of that and just break that. Sorry, that was a big mistake. What we really need to do, and this is the case for most graphics libraries, is like if the user exits out, then exit out. Otherwise, we have to do the thing. So we'll have like an update place, update game stuff. But we're not updating anything yet. And over here we'll do like draw game stuff. And that's basically how most games work. You should, like, again, it would be great if you're coming from Pygame and so you understand this stuff, but paint, great. Oh my god, why is this so big? Okay, so basically the way most games work is you have a, I don't know how to visualize this. You have a game loop. I don't know how to visualize this. Let's just make a box. Game loop. Wonderful. And in the game loop, you're going to be doing very specific things every time. So the first thing you'll do in most game loops is just get user input. And then what you'll do is you will update everything. Oh boy. Update. This will be like updating anything in your game, really. Players, enemies, stuff like that. Updating their positions, updating their like attacking situations, just updating everything, making sure that everything is up to date. And then the last thing, which is like the only thing the user really sees, is you draw. You draw everything to the screen. And you go back and forth. This is like a loop. Sure. Why not? Yeah, fine. That's a loop. That's your game loop. So you'll get user input, you'll update everything, and you'll draw. Now, obviously, in our game, right now, the only input that we're getting is if the player closed. And we're not updating anything yet because there's nothing to update. But we should draw something. So so the way to draw stuff in Raylib is to do rl.begin drawing. And then we do, so that basically says, Raylib, we are now about to draw. Now important, you always need to remember that at the end of your drawing thing, you have to do rl.end drawing. I don't even remember that those are the functions, but that's what's great about Raylib, that the functions are named very intuitive things. Begin drawing, end function, end drawing. And then we'll say rl.fill screen, this one, rl dot, what's the fill screen function? rl dot clear screen? Clear background, there you go. rl dot clear background, and then this gives you a color, so let's just do rl dot red for now. So we're going to clear the background with a red color, and this should do it. Wonderful. So now we have a 500 by 500 window, connect 4, red background. Now, okay, great. So now what we can do is, just to get a good sense of stuff, let's draw a circle. So RL, oh, no, not in the update place. In the drawing place, after you clear the background, it's basically like the clearing the background will happen first, and that's like your bottom layer. And then you'll do something after that, which will be drawn on top, and then drawn on top, and then drawn on top. Everything will be drawn on top of that. So the next thing we want to draw is, let's just do rl dot draw circle. The center, let's just do 100, 100, and the radius, let's just do like 20, and the color, let's do rl dot black. We'll draw a black circle. Wonderful. So now we have a black circle at 100, 100. Now notice the origin in Raylib is just like the origin in Pygame. It's up here. It's in the top left, not in the bottom left, as you would probably think. It's in the top left. So these are negative y values, and as you go down here, y increases, and as you go over here, x increases. So this would be 0.500, 500, and we can illustrate this by saying over here, let's just do x. This is a very long. We're not even getting to the connect 4 yet part, but connect 4 part yet. There you go. X colon equals 0, y colon equals 0, and then down here in the update place, so this is a great place to update, we'll say x equals rl dot get. I wonder if we could just do x comma y equals rl dot get mouse position. No, because this returns a vector. rl dot get mouse x, comma rl dot get mouse y, and this has to be cast to an int, apparently. Great. So this line over here, rl dot get mouse x, this will get the mouse x position, and this will get the mouse y position. And then we'll throw that into x and y over here. You should know all this because you know how to code. And then instead of putting the 100, 100, we'll do x, comma y. And what's the problem here? This wants an int32. So let's make this, what does this give back? Int32. So instead of doing colon equals, we could just int32. This is a terrible way to do it, but whatever, int32. And then we'll get rid of the casting to an int here. That way we won't have to cast and then uncast, and they'll only be, there you go. Just Golang stuff, making sure all the types are in order. Great, so now we should be drawing a circle at the mouse position. So let's see, we should be drawing a black circle at the mouse position. There you go. See, pretty cool. And just to illustrate my point further, fmt.println x comma y. What is my point? My point is that the origin is 0, 0. So as you see over here, these are low values for x and y, as you can see down here. And as we get bigger, they increase up until like 500, 500, which is the size of our window. So great. So this is how you make a window in Golang. So we are going to make our connect 4 window now. And it's a little bit more important than you might think. So I'm going to make a new file. I'm going to call it constants.go. This is where we'll keep all our constants. Package main. So const, and this will allow me to just declare a bunch of constants at once. So the first one is width. Let's make the width. The width needs to be. Okay, if you think about Connect 4, where is my Microsoft Paint? How do I just clear everything? I want like it to be really big. How do I make the brush? No, I don't want that. I want it to be significantly bigger than that. How do I just erase everything? That's what I want. Can I just make a big square? No. How do I don't know how to use Microsoft Paint. I have no idea what I'm doing. I I have absolutely no clue. Maybe I could just make like a really big white thing. Oh my god. Don't save. Let's just make a new one. What am I doing? Sorry about this. As you can see, I'm not very good at this. I want a table. Can I have a table, please? No. Fine. So if you think about Connect 4, it's basically a grid. It's a 1, 2, 3, 4, 5, 6, and then it's a 6 by 7, right? Yeah, six rows, 7 columns. 2, 3, 4, 5. Oh my god, it's terrible. 6, 7. 1, 2, 3, 4, 5, 6, and this one's extra. You know what? Pretend that this is 6 and this is 7. You know what? I'm just gonna show it on. I'm just gonna show it on the Connect 4 game that I already made. Unbelievable. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So the Connect 4 grid is a 6 by 7, and we have to decide how many pixels we want each one of these like boxes to be, essentially, right? So I'm just gonna choose 100. Just out of the top of my head. I mean, not out of the top of my head. We've done it. I've done it before, but basically, randomly choosing 100 to make the grid size. That's fine. And what we're gonna do is we're gonna make a window that, in terms of its width, is going to be 100 because there's 100 grids times 7, so 7 times 100, right? In terms of the pixels, in terms of the width, and in terms of the pixels, in terms of the height, it will also be 7 times 100 because there's 6 of these, and I want another one for this top thing, right? So great. That was a long way of me justifying the reason why the width is going to be 700 pixels. And the height is going to be, guess what? Height is going to, nope, I want everything to be capitalized. Height is going to be, guess what? Also 700. It'll be a 700 by 700. Why are these the things? Well, because the grid size is going to be 100. The rows, we will have 6 rows. And the calls, we will have 7 columns. Great. Let us, I'm trying to think of the best way to do this, because in my head when I'm coding, I would code like all the constants I need, because I know what constants I need, but I don't want to make it like we're just programming a lot of constants that you guys don't know why we're doing that, so I'm not going to do it that way. First things first, delete all that. The hello world thing, basic stuff, just I was showing how it works, and we're going to make it different. We're going to make this basically object-oriented, but it's Golang, so there aren't really any objects. So instead we're going to have a struct, and this struct we'll call game. This will be our game struct. And the game will have a few parameters. First of all, it will have running, which will be a run. I don't even know if it's 2 ends. I'm just going to do 1 end, running. Nope, doesn't look right. 2 ends, running. And that will be a Boolean. Wonderful. So great. That's all that the game really needs. And then we'll have a function, func, g star game, and we'll call this init. Again, I'm coding like I'm Python. I know this isn't really how you're supposed to do it, but this is how I'm doing it. So whenever we initialize the game, we'll initialize running, g.running, to true, and we will do rl.init window to the value of width that we set in our constants. Why is this breaking? Undeclared name width. It's not undeclared, it's right here. I misspelled it. Width. There we go. Width. Bro. Hey, it should be good now. What's your problem, dude? Not enough arguments. Oh, yeah, well, I haven't finished yet. Height. And title, well, let's make that a constant as well. What will our title be? Title is going to equal connect 4. Awesome. Height. Title will be title. Awesome. Now since we made a init function for our game, we should probably, and this is not always the case, but in this particular case, we will make a close function for our game. G star game. Close. and this function will do one simple thing. It will just rl.close window. Right. So since we init a window in the game.init function, we should close the window in the game.close function. And we could use this function to handle anything we want whenever we want to close a game, which is great. So like we could, I don't know, close any files that might have been open during our game. Handle stuff whenever you want your game to close, basically. It's great. Now, func g start game loop. This will be our game loop. This is where all our game loop stuff will go. There's an extra L here for no reason. Now, the first thing in our game loop will be handling user exiting. So if rl.window should close, then, you know what, wait, sorry, hold on. For g.running, this is our game loop, while the game is running. If rl.window should close, then g.running equals false. And let's also return. Let's just return out of this function because we quit the game and we don't want to do anything else. After that, this is where we'll put our update stuff. Update. You know what? Let's do it this way. Yeah, let's do it this way. Let's just do this stuff right now. Func g star game. This will be our update place. This is where we do all our updating stuff. Update. I don't know how to type. And for now, there won't be anything here because we haven't done an update yet. So let's just do that here. G.update. So we're declaring the function down here. We're calling it up here. Great. And now let's make a very similar one to this, but it will be called draw. And in the draw thing, we'll do rl.begin drawing, and then defer rl.close. Not close. Close drawing? Close drawing? Close. No. rl.end drawing. Great. And then let's do rl.clear background. And what should our color be? Well, let's make that a constant as well. Not a constant, but let's put that in the constant thing, because our background will be kind of constant. Var bg color equal, which will be of type rl.color equals, and you see how it imported that instantly when I typed rl, because it knows from this file what rl is. So rl.color, and it will be rl.black. Great. And then over here we could do bg color. And then up here, let's do g.draw. Great. So this is our game loop. And this will be the only thing that we actually call in our main function. Maybe it wasn't a good idea to put the game type, the game struct, in the same file, but whatever, I did it, so now it's here. Fine. Oh, also, one other thing that we should do in our init function is set the FPS. Set the FPS of our window. So let's do it over here. rl.set. How do you do this? Set target. I think this is, yeah, set target FPS. And this takes in an FPS, so type in 32. So let's make this a constant as well. FPS equals 30. We don't need a high FPS game. This is a turn-based game. So FPS. Awesome. I think we have everything. So let's just do this. Game equals a game. An instance of game. Game.init. Defer game.close. Game.loop. Great. So we're making a new game, we're initting the game, we're deferring the fact that we will eventually someday, possibly in the near future, want to close the game, and then we're calling the loop function for the game. Now let's run this. Let's see what we get. Something's broken. This should not be happening. What did I do wrong? Oh, I don't know why this stuff is outside of the for loop. That makes no sense. Command Control C, exit that broken. This stuff is supposed to be in here. Silly me. Silly Alicia. Great. So now, yeah, exciting. Where'd everything go? Everybody come back. I wasn't done with you guys. So great. So now we have our window. It's a 700 by 700 black screen window, but now it's set up in this struct that we have. I keep on wanting to call it a class, but it's not a class. It's struct. So now we can do some cool stuff. We need to think of a way to visualize our Connect 4 board. So let me pull up. I don't like pulling up the thing every time. I don't like pulling up the game that I made last time every time because I find it not good, because I don't want to just show what I made previously as my way of explaining what I'm about to do. So I'm gonna let's make that a little bigger. Great. This is not to scale because I'm making it taller than it actually is supposed to be. Did Khan Academy use Microsoft Paint? No. Oh, okay. 1, 2, 3, 4, 5, 6. We need to do one more, 7. And then 1, 2, 3, 4, 5, 6. Okay. So this is basically our board, and we need a way to know, first of all, the board. Second of all, is there a piece in this spot? So is there an X in this spot? Is there a Y in this spot? Like X and Y are player 2s, or is it empty? Or are all these spots empty? So the best way to do this, in my opinion, and in everybody else's opinion that you'll ever see a tutorial in any language whatsoever about this, is going to be a 2D, I don't know what it's called in Golang, array, list, matrix, whatever you want to call it. It will be 2 dimensions of lists, and it will be populated originally with 0 values for all of this, which will show empty. A 1 value will mean player 1 is in that location, and a 2 value will mean player 2 is in that location. So let's set this up. So the first thing I'm going to do is I'm just going to draw the basic board that will have nothing in it, basically. It will be just like a blank thing. And to do that, I'll come over here and I'll do, no, I want to do this after I clear the background. Hold on. rl.draw rectangle at 100, 100, with a width, a height of height minus 100, and a color of rl.blue. Let's just do blue. So what is this going to do? Well, I'll show you. That's not supposed to happen. Sorry, 0, 100. Great, so this is drawing, starting from 0, 100, we're going 100 down. Actually, I should make this even better. Instead of that, it should be grid size. 0, grid size. We're going down 1 grid size, and this will be height minus a grid size. And so what we're doing is we're leaving 1 grid size up top, and we're just drawing the rest of the board. But not only is this board empty, this board has no information in it. So we need to give it its information. To do that, we will make our game board in our game struct. So let's call this board. We're going to make a new thing. It will be board. And this will, what will this be? This will be a 2D array of int 32s, let's say. Great. So now, in the init function, when we initialize our game, we need to initialize our board to be empty. So for row, colon equals range of board. Row equals, I think this is the syntax, make, no, not row equals, but board index row equals, not board, for g dot board, because we need to reference the game's board, g dot board, equals make, and the size will be, oh, I messed this up. First of all, g dot board equals make a 2D thing, and how many, this is basically going to be, the size is going to be how many rows are there, because that's going to be the first dimension of this two-dimensional thing. So the size in this case is going to be the amount of rows, which remember we have as a constant of 6. Great. And then for every row in the board, 1 row, 2 row, 3 row, 4, we'll have the columns. And so g.board index row will be make a list of integers with the size of calls. And this will automatically initialize the board to be a board of 0. So let's do fmt.println board. G.board, sorry, g.board. Great, so as you can see, this is actually really badly done because it doesn't look like a board at all, but yeah, no, I don't like that. We're gonna set it up a little bit better. For row colon equals range g.board fmt.println g.board index row. I don't know. I feel like that'll do it better. Yeah. So as you can see, we have this basically connect for board representation as a two-dimensional list of stuff, of numbers. And basically 0 will signify empty. I'll make it so that, well, we will make it so that 1, if this spot has a 1, that basically means that player 1 has moved there, and if the spot has a 2, it will mean that player 2 has moved there. So let's make that a constant for now. Not that, but here, I'll show you what I mean. Constants empty equals 0. Great. Now, great. So now, right. So now we have the information that 0 signifies empty. We have that information because we created that information. So now let's draw the board a little bit better. So after we draw a rectangle, we want to go through the board. So for row colon equals range g.board for every row in our board, for call colon equals range g.board index row. And for this thing, so now we're looping through and we're getting each one of them. We're going like a typewriter. So let's do it. If g.board index row index call equals empty, then I want to draw a black circle at its location, but not just its location. We have to scale things to the size of our board. So we'll do RL over here, RL dot, let's make this a little bit neater. RL dot draw circle. So what's its x position going to be? Well, its x position is given by the column, right? So if I do call over here, but I don't just want the column, I want the column times the grid size, right? Because if it's like 0, I want the 0th column. But it's not just going to be column times grid size. It's going to be column times grid size. I mean, you know, let's just do it this way first, and I'll show you the next part. So column times grid size. The height, for now, let's just do row times grid size. And this is not going to work, and I'll explain why. Grid size. The radius will be, I don't know what the radius should be. I mean, obviously the radius should be a factor of the grid size in some way. Grid size times, let's say, I don't know, 7/11ths. And the color will be RL.black. These stuff have problems. This needs to be an Int32. It needs to be cast as an Int32. So let's take a look at this. It's not going to work. There are going to be like a few problems here. I know what they are, and we'll fix them. Okay, so first of all, way too big. Shicks. Okay. 5/11ths. Okay, I'm okay with this size. Now, few problems. First of all, this guy's cut off a half. Why is that? Well, because the center, the first time, for the first column of every row, the x center is going to be 0, because it's the 0th column, 0 times grid size, which is 0. So the center x is 0. We need the column times grid size plus half of grid size, because we need to get it into the center. So let's first implement that. Column times grid size, I'll just do over here, plus grid size over 2. I bet that will work. So plus half of grid size, right? All right, now let's run that again. And this time, everything should be in line. Great. So now we have everything in the thing. Now we have another problem. This guy's cut off at the top. Why is that? Well, same reason why this guy was cut off in half. It needs to be that. Same reason. Plus half of grid size to get into the center, because the first y is going to be 0 times grid size, which is 0. So we need to move it down. So same reason, same exact reason. This plus grid size, grid. I'm sorry if I'm not explaining this well. Over 2. Get it down. Because I feel like you, whoever you are you're trying to learn Raylib and how to make Connect 4 at the same time, so it's probably a little confusing. I apologize for that. Stick with it. You can do it. I believe in you. I know I'm not explaining it very well. Okay, so now we have another problem. What's our other problem? This guy is hidden. There's nothing here. Why? Because they're all up here. Maybe you can even see it. No, that's just my mind playing tricks on me. No, maybe you can. No. So yeah, they're all up here because we started at 0, 0. So we need to offset the y by a full grid size. We need to get everything down because of this layer up here. So maybe you should be like, nah. Yeah, anyway, so this whole thing, the y needs to be offset plus another grid size. And now we finally have our board as an empty board. Great. Okay, so now let's do a little bit more. So, oh boy. Now I wonder, should our players be structs, or should I just, because we only have 2 players, so let's just like hard code it maybe. I don't know. I think I want to make my players structs. Yeah. So let's make a new file. Player.go package main struct player. Nope, that's not the syntax at all. Oh boy. Type player struct. There we go. Each player will have an ID, which will be an int 32. Why? So what's the ID going to be? Well, for the first player, for player 1, the ID will be 1. And basically this will check, this will be the thing in the board that represents which player it is. And then as well, every player will have a color. Color. This should probably be capitalized. Color, which will be of type rl.color. So like player 1 will have red color, player 2 will have yellow color, etc., etc. Great, that's it. That's all I can think of. So let's make our players. So in the game will have player. Maybe we should have like players. No, let's just do player 1, player 2, player 1, which will be a type player. What's wrong? Did I misspell player? Player. No, I didn't misspell. Oh, this is not the place to do it. I'm in the wrong place. I should be here. I'm supposed to be here. Yeah. So the game will have a new. I don't even know what it's called. Parameter, type, thing, variable. I don't even know. So player 1 is going to be of type player. Player 2 is also going to be of type player. Okay. And now, in the init function, whenever we initialize, we should initialize our players as well. So player 1, g.player1 equals a player, and its ID will be 1, and its color will be color is going to be rl.red. And let's do the same thing for player 2. G.player2 is going to be a player, ID will be 2, and color will be yellow. Great. So now we need to make it over here. When we check if it's empty, we should check the other things as well. So else if g.board index row index column. You know what, instead of like getting this every time, which will take a lot of computation, let's just do let's just make it a variable and let's just check it again. We could honestly probably use a switch statement for this, but I'm not gonna do that. Why? Because I'm an idiot. I just like if statements, and there you go. So value colon equals that, and let's check over here. Value, if value, this makes no sense. This makes no sense. This makes no sense. I really messed this up. Hold on. If value equals empty, if value equals g.player1 ID. So if the value is g.player1 ID, then we're going to draw a circle. Draw a circle of player1.color. It's going to be right here. g.player1.color. And then else if, this will be the same just for player 2. Else if value equals g.player2, then over here g.player2.color. Okay, we shouldn't see anything different now. It's basically the same. All we've done now is we've made like player structs and initialized them so that the game has players. But for example, if I go up here and I say over here, and when we initialize our game, if I initialize the board g.board index, let's say this is going to be the wait, hold on. Is the first index the X or the Y? I think the first index is the Y, right? Because that's the row, and the rows are up here. So the first index is the Y, basically. So rows -1, index, let's say 3. So if I set basically the bottom middle thing to be g.player1.id, then we should see over here, yes, it's red, because in this place, if I print fmt dot println g.board, so let's rerun this. As you can see, or as you will see, oh well, this is not a very nice thing, but the bottomest row, the last row, and the middle column has a 1, because that's the first player's ID. And since it has a 1, our game knows to draw it as a red circle instead of a black circle. Cool? Cool. Great. So now we have that implemented. So, as a result of this, let me just check the stream. So is the chat not showing up? Because I'm actually surprised that no one's come. Huh? No one's come. All right, I'm cool with that. Cool. So, as a result, awesome. Right. Let us now handle for user input. So if the user clicks the mouse button, it should drop a piece into the thing. This is going to take a lot of code, actually, surprising amount of code. So the first thing we should do is we should keep track of whose turn it is. So let's do turn, which will be of type int32. And then when we initialize the game, turn will be set to g.player1 turn equals g.player1.id. G.turn. Great. So now we're keeping track of the turn, and it will start off at player 1's turn. And what we can do is we can say that we should You know what I'm going to do? I'm actually going to make not only individual players, but I'm also going to make a player list. players. This is going to make our code a little bit tidier, I think, which will be a list of player. And then after we initialize our two players, we'll say g.players equals a new list of players. And it will have in it g.player1 and g.player2. Why will this be important? Well, for example, down here, instead of having these two other if statements, I could do else. If it's not empty, we could say rl.drawCircle, and it will have the color of g.players index value -1. What's wrong here? Dot color. So g.players index value -1 will give us the player, and then we'll get the color of that player. Why is it value -1? Well, because if the value is 1, that means it's player. That means it's player 1, and player 1 has the index value of 0 in our list. Okay, so great. So now we got rid of that extra. We got rid of those double if statements, and now we only have an else statement, and it should still work just as good, which you can't see because of the thing, because there's nothing playing it. But anyway, the reason why I did that mainly is because now, in the draw thing, I want to draw a circle at the mouse X position, up top, in that top strip, with the color of whoever's turn it is, just so that we have a nice visual indication. So rl.drawCircle. Center X will be rl.getMouseX. Center Y will be grid size divided by 2. Obviously, because the center of the Y is going to be just one thing divided by 2. The radius is going to be, we should probably make this a constant, so, right, because this is the radius of the thing. So up here, nope, not over there, over here. Radius equals that. Now over here, instead of having this, we could say radius. And over here, we could say radius. And over here, we can also say radius. That way, if I want to change them, I could just change one value in the constant's place. And the color will be the same thing as over here. Or no, it won't be value this time. This time it will be turn. g.players index g.turn, whoever's turn it is, -1, because if the turn is 1, then that's player 1, and if the turn is 2, then that's player 2, and we just offset it because of indexes, right? So g.turn -1 dot color. And this should give us a nice indication of whoever's turn it is. And as you can see, it is currently player 1's turn. And you see how it follows the mouse, and it's very nice. Oh, very cool. Great, so now that we have that following the mouse, how long has this been going on? How long have we been doing stuff here? It's already been like an hour, right? Yeah, it's been around an hour. Okay. And we're only just now getting to the user input. So, finally we get to use the update function that we made so long ago. So in the update function, we'll say if rl dot is mouse button pressed, yeah, that's the function, is the mouse button pressed, and which mouse button do we want? We want rl dot mouse left button. So if the left button is clicked, then quite simply, what should this be? What's the best way to do this quickly? Because our mistake could say that if the turn is player 1's ID, then the turn should be player's 2 ID. But otherwise, I bet we could just make it so that we could say g.turn plus equals 1. And then we could say g.turn modulus equals not 2, but 3. If it's 3, I want it to be no, this is terrible. For now, if you press the mouse button, we're gonna switch turn. And oh boy. Hold on. Sorry. So right. If g.turn equals g.player1 ID, then g.turn equals g.player2 ID. What happened? No, not equals, just simply equals. Else, same thing, but the opposite, which happens a lot in coding. Great. So now with that implemented, we should be able to see that whenever we click, not doing it. Same thing, but the opposite, buddy. Let's try that again. Boink, 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 boink. So you can see that it's changing turns. Now, obviously, we still need to implement the falling down thing. But let me just talk about what we just did. If you remember in our game loop, we're checking if the user closed the window, and if he did close, we stop running the game. Then we update, and then we draw. So until now, we've basically been working only in the draw function, making sure that we could draw the board and stuff like that. We've organized the players, and now we're working on the update function, which gets called right before the draw function. And over here, we say if the mouse button is pressed, then for now, all we're doing is switching turns. For now, we should implement the dropping down mechanism, the way that we get, yeah, so let's do that. What's the first thing we need for that? Well, we need to know which column the mouse is currently on. So first of all, we'll switch turns at the end of this if statement, we'll switch turns. Let's get the column. Get col. fmt.println rl.get mouse x. Why do I want to print the get mouse x? Because honestly, the column that we've selected is dependent on the mouse x position, right? So let's see. 46, that's the pixel value. 150, 256, 352, 444, 559, 644. So I don't know if you noticed this. I noticed this very quickly, and I was actually really happy when I noticed this. It's like, oh my god, this is really cool. But the 100th value, not the 100th value, but the value in the hundreds place is the index value of the column of our board. Remember, our board is a two-dimensional matrix. And so over here, this is the 0th index. As you can see, it's like 10, meaning the 100th value, the value in the hundreds place is 0. 21, 39. It's always 0 up until we cross the line into this column, and now it's 121, which means the index value is 1. This is the 1th column, right? And then 2, right? And then 3, 4, 5, 6. So what we could do is we could say col equals rl.get, not player, but mouse x divided by 100, because we want the 100 place thing. And this will be an integer. Since this is an integer, the whole thing will be casted to an integer, I believe. Right, yeah, so since this is an integer, it'll just be an integer version of that. And we could print out the column now. So let's do that. Print col. And over here we have 0 column, 1 column, 2 column, 3 column, 4 column, 5 column, 6 column. 7, 6, 5, 4, 3. So this is the 0 column, this is the 1 column, this is the 2 column, this is the 3 column, this is the 4 column, 5 column, 6 column. And you can see it's being printed over here, which is great. So that was super easy. We got the column super easily. I actually want to make that a function. So we're going to do that over here. Func g star game get col. And this will return, I have to tell what's going to return, int 32. You're going to return an integer. Return rl.get mouse x divided by 100. So that's our function, and I just like making things into functions. G.get col. Great, so now we have our call, and this will work the same way as before, as I could show you. Okay, next step. Based on our column, we need to get the row, because the row could either be the bottom row, or it could be the one above it, or the one above it, depending on what's below it, right? So the first thing we should do after we get the column is make sure that the column is valid. Make sure it's a valid column. What would be a non-valid column? Well, it would be a column that's full, right? So we need to make sure that the column is valid. So let's make a function for that. Let's make a function for that. Func g star game is call valid, and this will take in a column, which will be represented as an int32, and it will return a boolean. I don't think we have to handle for like things breaking, like if you pass in like a too big of a column, like an index value that's not valid at all, like if you pass in like 100 as the column, that will throw an error. Probably, like, I'll show you why. So let's say if g.board index 0 index col does not equal empty. Yes. In fact, not even if. Just return that. Return that. That is our criteria. What does, sorry, just to make it easier, what does this mean? This means that the 0th row, which is the top row, at the column, the top row at that column is not empty. In other words, if that's not empty, none of the stuff below it's empty. There has to be at least one empty spot. So if that's not empty, this will return false. In other words, it's not a valid column. If it is empty, then it will return true. In other words, this is a valid column. So why would this be a problem? What is the biggest problem with this function? It's the fact that we're just straight up using the column and the index value. If the user passes in a value of 100, that will throw an error because there is no g.board index 0 is index 100. That's like too big. But since this is like a game and all the inputs that we give it are confounded between this like window, I don't think that's a problem. We don't need a handle for that. We don't need to say like, if column is too big, just return like -1 or something, as in like you broke it. I think that this is fine. So that's what we're gonna do. So after you get the column, we should only continue if g dot is call valid call. We should only continue if this is the case. Everything else in the if statement should be inside of that if statement. Only if this is a valid column should we continue. Only if this is a valid column should we drop a piece. Only if this is a valid column should we switch turns. If it's not a valid column, don't do anything. It was just like a waste of a mouse press, essentially. Okay, so only if it's a valid column. Now, if it is a valid column, we need to get the row. Because just because we know that the top row is empty doesn't mean we know which row is the closest empty one. We just know that the top row is empty. So now we need to get the actual row. So let's make a function for that. Func g star game get, not capitalized, get row, and this will also take in a column, int 32. Whoop, int 32, and this will return an int 32 as our representation of which row. All right, so what are we going to do? We want to start at the bottom of our board and work our way up. Let's just return just 0 for now. We want to start, remember our is call valid checks this, but we want to know like which is the first one. So if I click here, we want to know which is the first one. So we want to start here and check, are you empty? No, are you empty? No, are you empty? No, are you empty? No, are you empty? And so on and so forth. So we'll just move all the way along. And to do that, we'll just iterate through our board backwards. It's a very easy way to do it. So let's do that. For row colon equals the length of g.board minus 1. Row, as long as row is greater than or equal to 0, row minus minus. We're going to go backwards. Wait, what's wrong? Oh, I said r. Row. If g.board index row index call equals empty, return row. And 32 of row, sure. Else, in other words, like if we go through the entire loop and if we try to get a row of a non-valid column, then we'll just return -1 as our row. So great. But we don't need to make sure that we don't get a -1 because we've already checked that it's a valid column. So let's just get the row. Row colon equals g.get row using our column. So now we have our column and our row. Awesome. So now all that's left to do is to drop a piece. So let's make a function for that. Func g star game drop piece. I'm not sure how to spell piece. I think that's how you spell piece. I don't know. This will take in a row and a column. Both will be in 32s. And what we want to do is we want to say g.board index row index column equals g.turn. Because whoever's turn it is, that's the ID value, right? Where's my error? Why do I have an error somewhere? Ah, because we didn't use row yet. So now let's do g.drop piece in the column and the row. I'm sorry, in the row and the column. Row, comma, column. Right. Because, yeah, so why is it g.turn that works? Well, that's keeping track of our ID value, right? G.turn keeps track of whose ID it is. So it's a great way to do it. Let's run it. Why isn't it working? That's not good. Strange. I think that we did everything, didn't we? G.board index row index column equals g.turn. That should have done it. Are we not getting a true statement for the fmt.println quote found valid call? Are we not getting a valid column? No, okay, it looks like we're returning that it's not a valid column, which is weird because it clearly is a valid column. I don't know what you want to tell you. It's clearly not full. So let's see. Let's see. Is valid call return g.board index 0, the 0th row index column equals empty. Not does not equal empty. Equals empty. If it's empty, then it's a valid column. Otherwise, it's not a valid column. I'm an idiot, but we all know that. Boom, 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 boom. Okay. So there you go. It's working. Obvious problem. We need a way to reset the game because we can't do anything now. So we need a way to reset the game if the board is filled up. We need a way to check if someone has a connect 4, which as you can see, they both do. And there you go. And so we need a way to check if the game is over in one way or another, and then we need a way to reset the game. So the easiest thing to do is just to check if the board is filled up. And I think I'm just gonna make a function. Func g star game, and this will just get valid calls. This will just get all the valid columns that we have. So, and it will return a list of int 32s. So this will just go through all the columns that we have. So for call colon equals g.board index 0, y index 0, because it doesn't matter. Like we're just going to go through the first row and check every column. So the first row. If I need to make a list. Valid calls colon equals a list of integers. If g dot is valid column call. If the column is a valid column, then valid columns that append. So append to valid columns call. So we're just going to go through all the columns and make sure that it's valid. What's wrong? Expected Boolean or ranged expression found assignment. Oh, sorry, colon equals range. And this needs to be an int 32. Because I am on a 64-bit computer, and so it defaults to 64-bit ints. Okay. Okay, and then after all that, return valid columns. So we are going to just get all the valid columns that we have. Why is this important? Well, because when the board is filled up, there are no more valid columns. So after we drop a piece, where do we drop our piece? Hello? Over here. So after we drop our piece, we can check here. Check game over. Let's make some more comments. Get row drop. I mean, the function is there. It should get the thing. But anyway, check if game over. So if g dot get valid columns, so that's going to return the thing. So if the length of all our valid columns equals 0, in other words, there are no more valid columns, check, I don't want to check game over, I want to check board filled. I'll be more specific. Then what we can do, what do we do now? I guess, okay, we could make a new thing that not only will the game keep track of is the game running, but is the game over. Over is also going to be a Boolean, right? And then when we initialize the game, g.over equals false. And then if it's a tie thing, then we could say g.over equals true. And we're going to have to make another thing to keep track of the winner also, now that I think about it. But anyway, what we can do now is we can say if g.over, if the game is over, return. Don't update anything. Else, this is just basically saying else, do all this. And then in the g.over thing, before we return, we could say, we can go over here. If the mouse button is pressed, while the game is over, then we can say g.reset. We have to make the reset function though. So over here, under the close thing, before the loop, func g star game reset. So we're going to reset the game. The first thing we do when we reset the game is we say g.over is no longer true, so equals false. Did I do this properly over here? Yeah, g.over equals true. So now g.over no longer equals true, now it equals false when we reset, and then we have to reset our board. g.board, sorry, for row colon equals range of, not range of, g dot, just range, board, for call colon equals range g dot board index row, g dot board index row index call equals empty. Great, so this will reset our board. Let's try this out. So as you can see, now the game is over, and there's nothing else we can do. If we click, it resets. Great, so that worked. We should have some like text to show that it's over. Okay, so let's do that. Let's make the text. So in the draw thing, sorry, this is the draw function. In the draw, I'm going to collapse all of this. These are all my helper functions that I don't want to see right now. Sorry guys, go away. Great. In the draw function, I want to draw all of this, no matter what. But if g.over, then I want to draw some text. Now the text will depend on how the game is over. So I want to make another thing, another variable to keep track of, and that will be winner. Winner. And this will be an int 32. I want to keep track of who won, if anybody won. So in the init function, g.winner equals empty. We'll start it off that the winner is 0. So remember, the empty is this thing. And then if it's tied, sorry, hold on. If it is tied, where do we check if it's tied? Right over here. Check if board is filled, then g.winner is going to be empty again, which it already is. But so now it'll be empty. And then down here in the draw function, I can say if game is over, then I could check who the winner is. If g.winner equals empty, then rl.draw text tie game. That'll be the text. The position will be, let's say, I don't know, 20, 20. The font size will be, let's say, 30. And the color will be rl.white. It'll just be a white color because it's neutral, because no one won. So let's check it and make sure this works. I need an auto clicker, please. Tie game, great, right there. And then if we click, it should go away. It went away. Awesome. Great. Now that that is done, let's check who won. So here, let's make a new function. Func g star game. Check winner. Check winner. Check to see if there's a winner, and this will return a boolean if someone won. So this needs to do a few things. Check all horizontal. Check vertical, like vertical. Check, and I know I'm going to organize it this way. Check negatively slope. Check neg slopes, and so like that'll be all things like that. And then over here, check pos slope. And then if after all of that you don't find anybody, return false. Okay, let's go through these one at a time. Let's knock them down. Here we go. Do I want to make these into separate functions, or should I just do it as one? I think I'm just going to do it as one. There's no reason to make them separate. I don't think I'll ever use one of them without like all of them. Right? Right? Right. Let's do it. So what do we want to check? That's a great question. So I want to do it like this. If I want to check all the horizontal, I want to start here and check, are all of you the same? In terms of like, are all of you not empty and the same? Are all of you not empty and the same? If you are, then return that someone won. If you aren't, then move over one column. Are all of you not empty and the same? No. Are all of you not empty and the same? No. Are all of you not empty and the same? And then after that, we're going to go down. And we're going to do the exact same thing. But notice we're not going all the way to the end. If we go all the way to the end, there's nothing left to check. Like nothing could be there. So what we want to do is, if going up until the range of the length would be here, we want to go up until the range of the length minus 1, 2, 3. Minus 3. Yeah, range of the length minus 3. So, and we want to check all the rows. So let's do this. For row colon equals 4 row colon equals, and we want to check all the rows, so this will be fine. 4 row colon equals range of g.board. Now we don't want to check all of the columns. We only want to check up until the length of how many columns we have minus 3. So let's say for col colon equals 0, column is less than the length, column is less than, not the length, but rather the amount of columns we have, cols minus 3, col plus plus, right? Yeah, plus plus. So now, okay, that's our for loop. And now we'll check if, I mean, you know what, let's just make this a thing. Let's just make value like a, here, var value, which will be of type int 32 equals 0. And now let's set the value up here. Value, you know, this was actually a waste of time. Yeah, no, forget the value thing. No value thing. If g.board index row index column does not equal 0, so if it's not empty, that's our first thing. If the first box that we're checking is not empty, and so now all we need to do is make sure that they're all the same. So this will be what it looks like. It will look like this. That one equals column plus 1. So is this one is this one the same as this one? So in other words, are you not empty, and are you the same? And are you the same, you two guys, and are you two the same? And so that will be exactly what we do. So, and this is going to be plus 1 equals plus 2, right? I'm just copying and pasting. And the plus 2, wait. So far we have 1 checked, 2 checked. How many are we going to do? How many are we going to do? This is plus 1 and 0 the same? Is plus 1 and 2 the same? Is plus 2 and 3 the same? That's all we have to do. Plus 1, plus 2. So, hold on. 0 and plus 1, 0 and plus 2. 0 and plus 1 and plus 2. Plus 2 equals g dot board index row index call plus 2. Great. So if you're not empty and all of you are the same, not all of you, not all of you in the sense like all of you, but all of you in the sense of like all you guys over here. If you're the same as you and you're the same as you, and by the transitive property that makes you the same as you. But anyway, if you're the same as you, and if you're the same as you, and if you're the same as you, then we're done. Then we have a winner. So if that's true, return true. And someone is going to ask, why don't we just return this whole big thing? And the answer is, I don't want it to return false until we've checked everything, until we've checked all the horizontals and all the verticals and all the negative slopes and all the positive slopes. So yeah, until we do that, we're not returning anything. So there you go. That checks all the horizontals. Boom, easy as that. Now let's check all the verticals. The verticals are going to follow a similar thing, except opposite. Instead of that, we're gonna go like this. Are you all the same? 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 So this time we're going to be checking all of the columns, but not all of the rows. We'll be checking up until the amount of rows we have, again, minus 3. This would be the amount of rows we have, minus 1, minus 2, minus 3. Boom. So this time we're checking all the columns. So for call colon equals range of g.board, not of, there's no of in Golang, g.board index 0. For call colon equals range g.board index 0. So just for all the columns that we have, check every single row of that column except for the minus 3 thing. So it's going to be basically the exact same syntax as up here. So let's just copy this. For row colon equals 0, row is less than rows minus 3, and then row plus plus. Great. And now this is going to be the same thing as this, except backwards. So the column is going to change now. Now the row is going to change. So row next column, not column plus 1, but row plus 1. Not column plus 1, but row plus 1. Not column plus 2, but row plus 2. Not column plus 2, but row plus 2. And not column plus... Ooh, there's a mistake here. It's supposed to be column plus 3. Whoops. And over here it'll be row plus 3. Nice that I copy and pasted. That way I was able to catch my mistake. What's wrong? Well, why is there a red message? What's wrong here? Expected semicolon. Why would you expect a semicolon? There are no semicolons. What? Oh, am I missing a bracket? Where am I missing a bracket? These two have brackets. Someone is missing a bracket somewhere. This for loop is missing its bracket for some reason. Great. Okay. Okay, so let's just make sure I did this properly, because I just found an error. So if row next column does not equal 0, row call plus 1, row call plus 1, row call plus 2, row call plus 2, row call plus 3, row plus 1 call, row plus 1 call, row plus 2 call, row plus 2 call, row plus 3 call. Great, so that's good. So that checks all the verticals. Awesome. Now let's check all the negatively sloped things. The negatively sloped stuff is going to be like a combination between the vertical and the horizontal, because it's a slope. So we're going to start here, and we're going to check all of you. And then we're going to move over one, and we're going to check all of you. Then we're going to move over one, we're going to check all of you. Then we're going to move over one, we're going to check all of you. Sorry. And then we won't move over one and check all of you because there's not enough left. So it's going to be like a combination. It will have the same limitations as both of them. It will have, here, look, it will, for row, colon equals 0. Row is less than rows minus 3. Yeah, I want to go through the rows first. Then row plus plus. Why less than 3? Because once we get to here, we won't go to here because there's nothing left to check here. There's no point. Similarly for the columns, once we get to here, we won't check this one because there's nothing left to check. Like there's not enough room. So we'll also have the limitation of this guy. Same limitation. Isn't that fun? I think that's really fun. It's great. So these both have the same limitations. And now, once again, we have like a combination situation. What's wrong here? Oh, why is this a square bracket? That makes no sense. It should be a curly bracket. And this shouldn't be an R. This should be a row. I don't know what's wrong with me. Great. So the same limitations, and also, funny enough, a combination of the two conditions. Because every time we move over one row, one column, we also move down one row. So let's implement that. So every time we move, so it's the same thing. Every time we move down one row, we should also move to the right one column. So it'll be the same number, just for both of them. And then over here, plus. I feel like these are much longer than the other ones I used to, than the ones in my other game. Hold on, let me just double check, because I feel like these if statements are really long. This is the other version that I have. Yeah, I feel like the ones we have over there are much longer. Why? Why? I don't know. I have no idea. Maybe it's because the dimensions of this one are smaller. Yeah, it's because this thing is bigger. If we just make that one. We just make this toolbar a little bit smaller. No, it's still really big. Hold on. Yeah, it's still really big. That's weird. What is... Maybe... Don't know. Don't know. Really, really weird. Am I doing too many things? Hold on. Sorry, this is bothering me. +1, +2, +3. That's so weird. How many indents are there? 1, 2, 3, 4 up until the if statement. And over here, 1, 2, 3, 4 up until the if statement. Yeah, same thing. Weird. Is my like font size just bigger on this one than the other one? Sorry. Yeah, maybe that's it. Maybe that's it. I don't think so though. No, definitely not it. Maybe I should even make the font size bigger so you guys can see it properly. That's way too big. I can't code like that. Sorry. If maybe I don't have as many spaces between all the conditions. I think that's probably it. No, I do. What is going on? What is different about these two? Hold on. I'm copying this, and I'm just going to compare them. So weird. So weird. Yeah, this one's like significantly shorter. Ah, because in my code I did R and C instead of row and call, because I'm able to understand that, but I wanted to make things clear in the video, so I'm doing row and call. That's fine. Silly me. Okay. Sorry about that. There was no point to me doing that. I was just curious, and I wasted all your time. I apologize. All right, positively sloped. So the positive slope is going to be the same as the negative slope, except reversed. I know, I'm an idiot. So instead of starting up here, we're going to start down here. And instead of going down rows, we're going to go up rows, which will be a negative number instead of a positive number, because you remember the whole thing with the origin is in the top left. So it's going to be the exact same. except we're going to start off on rows -1. Why -1? Because the index value is always -1. This is just a classic thing in coding. The columns will still be 0. It will go until as long as the row is greater than. Hold on. Oh no, this is complicated. This is annoying. It always hurts my head. Rows -1, rows -2, rows -3. We want rows -3. We don't want rows -4. Rows -1, rows -2, rows -3. We don't want rows -4. So as long as it's greater than rows -4, there you go. There we go. Then decrement row. You know, honestly, I should have checked each one of these whenever I coded them to make sure they were all working. But I guess we'll just check them all at once. Right, okay. So decrement, okay. And then over here, instead of going up a row, we want to go down. So down, and down, and down, and down. Great. That is all of them. I really should have checked them while I was coding them, but I didn't, and that is stupid of me. But now we're going to check them, so let's go. So after we drop our piece, before we check if the board is filled, we want to check if someone won. So check if someone won. If g dot check winner, if there is a winner, then g dot over equals true, and g dot winner equals g dot turn. Whoever's turn it was is in fact the winner. Now, why do we want to know who the winner is? Well, because down here, when we're writing things, I want to say else. If the winner is not that, else, I want to rl dot draw text. So if the winner is not a tie, then I want to do g dot players index g dot winner dot victory phrase. This should be capitalized. Victory phrase. Now that doesn't exist yet. We're gonna put that in. The position will be 20, 20, 30, and then over here for the color it will be g dot players index g dot winner -1 dot color, because again the winner needs to be -1 and it needs to be like that over here as well, -1. And then for player we need a new thing, so victory phrase, which will be a type of string. So every player needs a victory phrase. And then over here, when we are making the players, victory phrase equals player 2 wins. And then we need the same thing. We need the exact same thing, but we need the exact same thing, but player 1 wins over here. And victory phrase. Sorry, I need that, bro. Okay, cool. Now it will just use this victory phrase for whoever won, depending on who the winner is, right? Right. Honestly, I think we might have finished the game. Hold on. So let's just make sure that it's working. So, hold on. That, boom. Player 1 wins! Exclamation point. And then when we click, it resets, right? So now let's check a vertical win. Player 2 wins. Great. Now let's check a diagonal win. Shoot, I messed it up. Stop it. I clicked the wrong thing. All right. Anyway, let's just let player 1 win, and then now let's do the diagonal thing. So, boom, boom, and then boom. Player 2 wins because of the diagonal. And then let's check a negative diagonal. So this is going to be harder. 1, 2, 3, 4. So this is going to be a yellow player. No, what happened? That's hilarious. We went too far. What? That's crazy. We went too far. Hold on. it's actually possible to go too far. That's really interesting. Okay, so I didn't realize that. We're gonna have to handle for that apparently. So when we get call is valid, here, return call is greater than or equal to 0, and call is less than or equal to, is less than calls, and this. So we have to make sure that everything is working. In other words, the column is not too low. The column is not too low, it's big enough. The column is not too high, it's small enough. And there you go. That is so weird. I did not realize that that was an issue that I was ever going to have to come across. Okay, great. That should fix that. So what were we doing? Right, we were checking negative slopes. Boink. Boink. And last but not least, boink. Player 2 wins. So that's a negative slope. Honestly, we probably should go through the entire thing and make sure everything is working, but I don't want to do that. I don't think that's a problem. But we're done. Game's over. We finished. We completed the thing. Good stuff. So I think that is it. There's not anything else that right, one thing. As you can see, whoever wins, it's always the other person's turn the next game, right? Right. So I want to make it so that we randomize that actually. So let's import random. We could probably do that just by, okay, so let's import random. Quote, math dash rand. We need, so the first thing we're going to do is we're going to set the random seed. Rand dot set, that seed equals time, which is also going to be imported by itself. Time, see up there, just import time. Time dot now dot Unix. So we're going to get the integer value of the current time, basically, to set the seed, just so that the seed is always random, quote unquote. The seed is always not uniform. And then over here, we're not over here. Where are we? Whenever we win, not whenever we win, whenever we reset the game, we want to say g.turn equals rand dot int n32. So this will give me a range between 0 and I want the option of either 0 or 1, and I'll just plus 1 that. So I want a range from 0 to 2, not including 2, right? Because as you can see, it doesn't include 2. The parenthesis instead of the bracket means it's not including that one. So not including 2, plus 1, and this will give us the random turn. So let's try that out. Boink, 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 boink. Player 1 wins. It should be player 2's turn, but when we click, it's still player 2's turn, so that's fine because it's random. So let's see. Now it should be player 1's turn, but when we click, it's player 2's turn, right? And now it should be player 1 turn, but when we click, it's still player 1 turn. So it's random now, which is great. We're done. If you want, you can build this. So you could say go build everything. This will build this to an executable. And now you have a straight up, no joke, complete, I'm not kidding, we have a, and this is another thing that's beautiful about Go. It's so easy to make executables with it. So now we have a Connect 4 thing right here, an application. We have an executable. Move to desktop. Let's get to the desktop. Hold on. Minimize, 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 minimize. Ooh, someone was in the chat. I apologize. I follow this tutorial when the full bit is posted later. Great. Cool. So apparently people were here and I missed them. Apologize. Great. So now we have the full-on executable. It's right here. You can click it and sorry. You can click it and you can play Connect 4. It starts off with a thing. You have to like go build without the command line. But anyway, boom, baby, Connect 4 in the flesh, and we win. Player 1 wins. So I hope you guys enjoyed the tutorial. Leave a comment with any questions you have. Happy to respond. I think Golang is an awesome language. I wish there were more tutorials out there with it. Yeah, leave any questions in the comment below. We'll respond 100%. I don't get many comments, so I'll definitely respond. Hope you guys enjoyed, and have fun coding. Have fun with Golang. I love the language so much. Everybody should code with it. It's a great language. And yeah, I'll see you guys around. Bye.